So now to finish up lesson 11.2, we're going to look at the area of a sector. So this is very similar to where we found arc length. Now we're just talking about area. So it's kind of a cool application of area of a circle, just like the other one was a good application of circumference of a circle. So here it says the ratio of the area of a sector of a circle to the area of the whole circle is equal to the ratio of the measure of the intercepted arc to 360. So same as we saw before, here is our proportion that I'm going to stick with. So it's the area of this piece of the pie compared to the area of the whole pie, which we know the area of a whole circle is pi r squared, compared to the degree measure of this arc, okay, the measure of arc AB, to the measure of arc, to the degree measure of the entire circle, rather, the whole arc, the circle, which is 360. Okay, and then again, they multiply both sides by pi r squared, and that's how they get this one. But I'm not going to use that one. If it relates, but I personally have found with students, especially when we first learn this, it's just easier and it means more if you understand why it's happening and not just memorize it. Okay, so again, it's the piece, just one more time because then we'll apply it a lot. It's this area of this piece out of the area of the entire circle, hence pi r squared. And then it's going to be the degree measure of this piece out of the degree measure of the entire circle. Okay? All right, so they want us to find two things here. Find the area of the sectors formed by angle UTB. So they want us to find the area of the red sector and the area of the blue sector. Okay, so let's do red first. I guess, why not, right? Let's do it in red. That's better. Okay, so the red. So I'm going to do the area of that. Okay, now they want us to find the area of the sector, so I don't know that. So it's going to be x over the area of the entire circle, which they give me the radius, so it's going to be pi times 8 squared. Now I know we know that's 64 pi, but I'm just trying to lay it all out here. And that's going to equal the degree measure, that's a central angle, so that's 70 degrees, over the degrees of the entire circle, 360. And there you have it. Okay, so I can cross multiply here. I'm going to get 360 pi, sorry, not pi, 360x is going to equal, now I'm going to multiply 70 times 64 pi. But I'm going to leave that pi out. So 70 times 64, that gives me 4,480 pi. And again, the reason I'm leaving that out is, I'm leaving it in terms of pi, is because I'm trying to solve for this x value here. The sooner I round pi, the more off my final answer is going to be. Okay, so I want to keep it as exact as possible. Divide both sides by 360. Now at this point in my calculator, I'm going to do 4,480 pi. And let that leave that long decimal on there. It has it all calculated and computed, and divide that number by 360. So I've really avoided any rounding until this last point here where I get 39.095, so that's 39.1. Okay, now that's the area, so I want to write this in inches squared. Okay, so the area of that red sector there is 39.1 inches squared. Now to do the blue, I can do the same thing. Okay, so it's going to be x over, we know that this is 64 pi. It's going to equal, now if that's 70, this entire thing is 360 minus 70, obviously, so that's going to be 290 over 360, the total. Cross multiplying, 290 times 64 is equal to 18,560 pi equals 360 x. Divide both sides by 360. And my answer comes out to be 161.97. Okay, and that's inches squared again. Now what I could have done, I know that the area of the whole thing is 64 pi, which 64 pi, if I actually, now I can calculate it out, it's about 201.06. Okay, so what I could have done to find this blue section is I could have done 201 0.06, or better would be 64, minus the area of the red portion, 39.1. And if I just do that either as a check or as the only way to do it, I get this number here. Okay, so I didn't really have to do this whole thing, but it's a nice practice. Okay, so however you choose to do it. So let's use that concept whenever we look at this next one. If it's okay, I'm going to erase this. You can always go back in the video if you need to. I just want to have more room. So I find that the less there is on the screen, the less confusing it is. So the area of the red sector first. Let's do that first. So red. So it's 120 degrees. They give me my radius. So I don't know the area of the red sector, but I know the area of the circle is going to be pi times 14 squared. And that's going to equal 120 degrees out of 360 degrees. Okay, now what I am able to go ahead in here and do a little bit of simplifying, meaning that I can rewrite this as x over 14 squared is 196. So 196 pi equals, and I know 120 out of 36 is 1 over 3. That might make it a little bit easier, not necessary, but an option. All right, cross multiplying, I'm going to go ahead and I get 196 pi equals 3x, divide by 3, divide by 3, and so I find that x is equal to 196 pi divided by 3, 205.25. So the area of that red portion is 205.25 square feet. Okay, now let's just see, what is the area of the entire thing? 196 pi, the entire area of the full circle. Let me write that actually in a different color. The full circle is, I guess purple. The area of the full circle is 196 pi, which if we want a number so we can understand what that is a little more detailedly, 615.75, again, feet squared. So it makes sense that that red portion there is going to be 205. It looks to be, yeah, like maybe a little around a third. I mean, it is 120 degrees, so it is a third. 205 seems like a third, right? Even if I divide it by 3, I actually get that exact number. So yeah, everything matches out. So now when I go to do the blue portion, I could do this whole formula again, this whole proportion, or I can just say, well, I know the area of the entire circle is 196 pi. I'm going to subtract from that what the red portion is, which we have calculated out. I can either subtract 196 pi over 3, or I can use my rounded. We're not doing rocket science right now, so a few roundings aren't going to make or break anything too substantially. But the whole area, this is the whole circle, minus, I'm going to color this in red, the red portion is going to give me what's left, the blue portion. Okay? So if I subtract those, 196 pi minus 205.25, I'm going to get 410.5 feet squared. And again, I also could have just done 196 pi, divided that by, multiplied that by 2/3. And I would have gotten the exact same answer. So there's a lot of avenues to go about this problem, but there you have it. Okay, so that's finding areas of sectors, applying our use of area of a circle. Now let's go this way. Here they want us to find the area of the circle. They're giving us the area of the sector. So I'm going to say 35 over x equals 40. My equals look like 2's. 40 over 360. Multiply 40x equals 35 times 360 is 12,600. Again, off on my decimal point. Divide by 40. And I end up getting 315. So the area of the entire circle is 315 square meters. It makes sense that, 40 out of 360 is 1/9. And so if I do 315 divided by 9, I get 35. So it all maps out. We got it. Okay. Now I'd like to take a look at these last at least one of these, just to give you an idea for application here. So a rectangular wall has an entrance cut into it. You want to paint the wall. Now to the nearest square foot, what is the area of the region that you need to paint? So a good application. So the full area of this rectangular portion is 36 across the bottom and 26 going up the side, 10 and 16. So 36 times 26 is going to be 936 square feet. Now, if you buy paint for 936 square feet, that's a lot of extra because you don't need to paint this whole opening, this whole archway. So let's find the area of this archway. Okay, so this archway has a square at the bottom, and then this portion here. Okay, so they tell me that it's 16 feet high, as is marked here, and it's 16 feet across, which is why we said it's a square. So this area is 256. All right, now let's find the area of the circle. Okay, so the area of this, it's only a semicircle, so if I go ahead and calculate this, it's going to be pi r squared over 2. So pi times my radius is 8 squared over 2, which is going to be 64 pi over 2, or 32 pi, which, sorry, that looks really bad. 32 pi, my pi's didn't come out clearly, is actually about 100.53. Okay, so we're buying paint here. Again, it doesn't have to be, it's to the nearest square foot. So the area of this top portion, I can write in here, is 100.53. So I take 936 minus, I'm going to combine 100.53 plus 256. The area of this entire doorway here, this archway, is 356.53. And when I subtract that answer from 936, I get 579.47. This is all in feet, so square feet. So to the nearest square foot, what is the area of the region that you need to paint? We need to paint 579.47, which is going to be about 579 square feet. Okay, and then your paint sold per square foot, so you would figure out if a certain can of paint covers, you know, I don't know, 10 square feet, how many cans of paint, whatever it is you're getting. Okay, all right, so that's that. And we already did a lot with area, so just one more where we take a look at the area of a figure. If we look at number 8, if I find the area of my triangle, I'm going to do it in half pieces. So I'll find the area of the semicircle. Let's make that a little smaller. So this means I have pi times the radius squared, but it's only half of it, so it's 2. And I'm going to add to that the area of the triangle, which is a formula of 1/2 base times height. So all I need to do is sub in the values that I'm given. So this is going to be pi times 3.5 squared over 2, because the radius is only going to be half. And then I add to that 1/2, my base is 7 times my height, which is 7. And then I can go ahead and calculate that. 3.5 squared times pi divided by 2 is 19.24, and I'm rounding with, I just kept it all in pi on my calculator, so. And then 7 times 7 is 49 divided by 2, or times 1/2 is 24.5. And when I add those two units together, I'm going to get 43.74, and we're working in meters squared. Okay, so I did round here a little bit, but that works. Okay, all right, see me with questions. Great job, guys.